No, sir.
Okay, then let's just start with the next topic, that is physical properties. We are going to deal with physical properties of this uh, aldehyde and ketone. This is your physical properties. So if you are going to read NCRT, there is comparison between hydrocarbon, that is alkane, and then there is comparison between alkane and then it's your ether, and then aldehyde, and then ketone, and then alcohol. So I'm gonna just take the idea of that. This is your alkane, butane, and this is your methoxyethane, and this is your propanol. This is your acetone, that means propanol, right? Propanol. And after this is your propanol. Propane, one all or propanol. You know what? The one with the highest the one with the highest boiling point is this one, propanol, because it has hydrogen bonding. And then comes the propanol, that is acetone, and then propanol, and then this methoxyethane, and the lowest is this. And always remember this, the boiling point is directly proportional to molecular weight, and which is direct. If molecular weight is high, that means van der Waals force of attraction between the molecules are high. That means we need more energy to break that bond and to convert it into gaseous state, from liquid state to gaseous state. Is that clear? And these are all comparable, these are all of comparable mass. So this is it about it. And this is also important to note that in propanol, that means aldehyde, there will be hydrogen bonding. As you are going to see, if you have aldehyde like this, and this is present in water. So as you can see, this is your water, and you have another aldehyde that is like this. So as you can see, this will have delta negative, this will have delta positive, this will have delta negative, delta positive. Again, this will have delta positive, and this will have delta negative. So there will be a force of attraction that is called hydrogen bond. Is that clear? So the
Yes,
most
sir.
most boiling point is of propanol, because its hydrogen bonding is more than aldehyde. So I'm going to give you a question. Are you done with this, or are you writing it?
Yes, sir. Finish reading.
Now see, if I'm going to give you this, this is your butanol, and this is your butanol, this is your ethoxyethane, and this is your butane. You need to tell me, arrange this in decreasing order of boiling point. Decreasing order of boiling point. Please do this.
So it would be
Yes, tell me.
butane and ethane and then butanol.
Which one will have the
Butanol.
highest?
The highest butane.
Butane. As I told you in this one, the most boiling point will have of this, then this, and then this, and then this, and then this.
Okay, sir.
Hydrocarbon will have the least boiling point. So in this way, you can see butanol will have the highest boiling point. After that, butanol come because there is no ketone, and then ethoxyethane comes, and then your butane comes. That means hydrocarbon alkane has the lowest boiling point among this. Okay. Can we move to the next part?
Yes, sir. Finish.
Okay. Now see, we are going to study the chemical reactions. Chemical reactions. And it's very easy. So first chemical reaction that we are going to study is nucleophilic addition reaction. This is nucleophilic addition reaction. So nucleophilic addition reaction, as we know that we have carbonyl compound, either aldehyde or ketone. So as you know that this is more electronegative. Oxygen is more electronegative. What it will do? It will take electron from carbon. That means it will have delta negative and this will have delta positive charge. Since you can see the electrophilic center, that means the center or the molecules which are being lesser in electron or which are electron deficient molecules, if nucleophile is present there, that nucleophile will attack here. Are you getting my point?
Yes, sir.
Now, as you can see, since nucleophile attacked on carbon, this oxygen will have single bond now, and it took the electron of carbon. That's why it has negative charge. And since oxygen took the electron of carbon, so nucleophile will be bonding with carbon, and then the rest part will be as it is. This is your A, and this is your B. I'm gonna write this in the same way for this. As you can see that this will be your A, this will be your B. Please do write it. And if you are going to react this with H plus, so you can see this will be nucleophile, and as you know that this is negative, so positive will be attracted by negative and this bond will be formed. OH. After this is your B and this is your A. Now, one thing that you need to be careful is that this is your slowest step, and this is your fast step. Step 2. As you can see, this is slow, step 1, and fast, step 2. And rate determining step is the one which is slow. Are you getting my point?
Yes, sir.
Please do write it.
Yes, sir. Finish.
Very good. So now we are going to see the examples of this nucleophilic addition reaction and some of the nucleophilic addition elimination reaction. Okay. So first of all, I would like to uh, ask a question that reactivity. If you have seen that this is your aldehyde and this is your ketone. So in which reactivity, which one is reactive, more reactive towards nucleophilic addition reaction? Which one is more reactive towards addition, nucleophilic addition reaction? Can you tell me? Yes or no? If you have a nucleophile here and here, so it will be attacking on carbon and it will be attacking on carbon. So on which carbonyl compound, whether aldehyde or ketone, on which it can attack easily? Do you have any idea?
Aldehyde.
Aldehyde it can easily attack because there is hydrogen, and at the place of
Yes,
hydrogen
sir.
there is alkyl group, so there will be a steric hindrance. That's why. So I'm gonna write a point about this. Aldehydes are, please do write with me. Generally, they are more reactive. Please do write.
Yes, sir. Finish.
Very good. Now, see, I'm going to take some of the example of this reaction. So, write a small topics, some example or important examples. Addition and nucleophilic addition elimination reaction. Now see, we have the first example as addition of hydrogen cyanide. So I'll explain the reaction first, then I will write some point about it. So we need to do this addition of hydrogen cyanide in carbonyl compound only in aldehyde and ketone here. So as you can see, first of all, we are going to react this hydrogen cyanide with a base that is OH minus. That will give you, as you can see, this will be your Cn minus and H2O. How it comes? It's very easy to understand that Cn is more electronegative and electron withdrawing group, so it will have negative charge and this will have positive charge. So as you know, positive will move to negative. In this way, H2O will form and Cn minus cyanide ion. This is your cyanide ion. This is your hydrogen cyanide. This is your cyanide ion, which is a very good nucleophile as compared to this hydrogen cyanide. So, and this hydrogen cyanide is not that much good nucleophile and it's not that much reactive. That's why we reacted with its this base OH minus to make a or prepare a very good nucleophile. So here you just prepared this Cn minus. That means what do we call it? Cyanide ion. So now this cyanide ion is going to react with this carbonyl compounds, whether it will be an aldehyde here or ketone. So you are going to react this with Cn minus, and again the same play. This will have negative charge, and this will have positive charge. Delta negative, delta positive, you can call it. And this will be attacking on this, and oxygen will take electron from carbon. Okay, Nafisa, are you there?
Yes, sir.
Okay, now you can see that this bond will be broken. In order to add a new bond in carbon, we have to break the old bond. So this will be your CO negative since it took the electron from carbon, and this will be your Cn. And again, since it had act on carbon, it will give electron to carbon. Carbon initially was positive and gained the electron from cyanide. It will be negative, positive, negative cancel, and then again this intermediate, you can call it, is formed. So I'm going to write a point about this. This is your tetrahedral intermediate. The reaction is not completed yet. Tetrahedral intermediate. Now after this, you are going to react this with acid. That will be a reversible reaction. You know what is reversible reaction, right? Nafisa?
Yes, sir.
Yeah.
Yes.
That proceed in both direction, forward and backward. So in this way, you know that this positive will go to oxygen because that will have a that has a negative charge, and this what we prepared from this, and this is known as cyanohydrine. Cyanohydrine. So if you will be looking at the back exercise, you will be seeing that write some points about or explain these terms like cyanohydrine, and there are other terms like hemiacetal, acetal, and all. So please do write it. Then we will go for the next. There might be a question about this: why hydrogen cyanide is converted into cyanide ion? Why we didn't use HCN? Because HCN is very less reactive and it's not that much good uh, nucleophile. That's why we converted into cyanide ion and then reacted with carbonyl compound, aldehyde and ketones. Please do write it and let me know.
Yes, sir. Finish.
Very good. To write a point about this, aldehydes and ketones react with, wait a minute, aldehydes and ketones react with hydrogen cyanide to produce cyanohydrates. To produce cyanohydrates. This reaction occurs very slowly with pure HCl, with pure HCN, hydrogen cyanide. Therefore, it is catalyzed by a base and generated cyanide ion, being a strong nucleophile. That's why it will easily attack on the electrophilic center. Please do let me know when you are done with this.
Yes, sir. Finished.
Very good. Do you have any doubt in this?
No, sir.
Okay. So this was the first example, that is addition of hydrogen cyanide. Now the next example is, basically we are again going to add. So the second is addition of sodium hydrogen sulfide. Addition of sodium hydrogen sulfide. So if you have this what we call carbonyl compounds, either aldehyde or ketone, it will be reacting with NaHSO4, HSO3, that is sulfide. So what it will give, it's very easy to understand. It will give, as you know, that this will have delta negative sign, delta positive sign. So it will be CO negative, and then there will be like this. Now again, what you need to be careful, this will have positive charge metal and this will have negative charge. So negative charge is going with this part C. So can I write O negative was there, so SO2H. Can I write this? SO2H, and this will be basically your ONA. And after this, you are going to do the proton transfer. Proton transfer. That will be basically your this part. This will be going here and then it will be coming here. So it will be COSO2 and Na will be here and here it will form OH and this part will be as it is and its name is bisulfite addition compound, which is crystalline in nature. These are crystalline solid. Please do write it. Basically, what happens here as HSO as you know that this is positive, so it will go here and HSO3 I just wrote here. You can easily write it HSO3 as well. So can I write HSO3 as OSO2H? Are you getting my point? I just wrote it like this and there will be proton transfer. That means H will come to sodium and sodium will come to H at the place. Do let me know when you are done with this.
Yes, sir.
Very good. Now, the next is basically your addition of alcohols. Addition of wait a minute. What happened? Next topic is your basically addition of alcohols. So as you can see, addition of alcohol. If you have aldehyde RCHO, you are going to react this with HCl gas, hydrochloric gas. See, you are going to react this with alcohol in the presence of HCl gas. So what will happen? You will get an intermediate, as you can see. There is double bond. You know that this is doubly bonded like this. So this again will have the same thing. It will have negative, this will have positive charge. And again, you know that this R dash OH, this will have negative and this will have positive charge. So this positive will go with this. So as you can see, RCH is there with O minus, which going, OR dash is going, and this OH minus is coming with this. So this is form OH. And this is known as hemiacetal. Acid. After this, if you are going to again react this with the same alcohol R-OH and then in the presence of acid, what will happen? It's very easy to understand. So this will have positive charge and this will have negative charge. This will have negative charge. This will have positive charge. So this wait a minute. Can I change? Can I do this? OR dash. Okay. Now see, and if you are going to do this, this hydrogen will have positive charge and this oxygen will have negative charge. So as you can see, this will attack here, not here, because if you are going to attack this part, this part here, it will be as it is in the previous one. Or R dash will replace R dash, nothing will change. So as you can see, this will be RCH and OR dash as it is, and there will be OR dash. If you are going to attack on the top, that means R dash will be replaced by R dash, nothing will change. But if you are going to replace hydrogen with R dash, you will get a new product that is known as acetal. This is your hemiacetal, this is your acetal, along with as a byproduct H2O will be formed, because this H and this OH will combine to form byproduct H2O. Please do write it.
Yes, I finished.
Very good. Now the next uh, example of this reaction is your addition of alcohols. We are done with addition of ammonia and its derivative. Addition of no, we just did for aldehyde only. Now we are going to do for ketone as well. So you know that ketone is like this, RC double bond R. So this is your ketone, and if you are going to add alcohol, we will use this alcohol dihydric. So it's very easy to understand. Same process is going on, reacting in the presence of HCl gas, which is dilute HCl, and in the presence of dilute HCl. So just you need to take care of this CO and O will be there, R and R will be here, and then CH2 CH2 forming like this, and this is your H2. So this is your basically ethylene glycol ketal. Now as you can see how the reaction took place, it's very easy. So this will have basically your negative and positive charge. You can make it. This is your positive and this is your negative, and this is your positive, this is your negative, and this part, as you can see, wait a minute, don't go for all of this, just make it like this. This will have negative charge, this will have positive charge, and as you can see, this will be moving like this. So this will have negative and this will have positive. So as you can see, RCR will be like this, and O negative will be like this. O negative will be combining with this CH2. It will be like this CH2, and CH2 was there. And you can see this will be moving like this. So this negative, this conducted this, and this negative will be attacking on carbon. This negative will be attacking on carbon. So it will form like this bond. It will form bond like this, and this H plus and this OH minus will combine to form the byproduct H2O. So in this way, ethylene glycol ketal is formed.
Sir, can you explain again?
See, it's very easy to understand. Just do me a favor, please write this part first, then I will again explain. Okay, not this part. This part, just write this.
Okay, sir.
Wait a minute. You can show this bond, it will have delta negative delta constant.
Yes, sir, finish.
Very good. As you can see, we had this C double bond O and this. And this is your 1,2 ethane diol, right? So what will happen from here? H2O will be eliminated, so it will form CH2. Can I write this as O negative? And this is as CH2 plus. Can I write this?
Yes, sir.
Now, this will have negative sign, this will have positive sign. So this negative will be attacking on this carbon and this positive will be attacking on this carbon. You can see the path is crossing each other, but it's not like that. I'm gonna explain it, elaborate it more and more. I'm gonna write this part as, you can see, R, C, R, and this will be O negative, this will be or C positive because it took electron from carbon. And now I'm gonna write this as, you can see, this will be our CH2 plus. I'm just writing it in opposite, and this will be CH2 O minus. Can I write this part as this? Yes or no?
Yes, sir.
Now what you need to, negative will attack positive, negative will attack positive. So what you will get? O CH2 CH2 ethylene glycol cation.
Yes, sir, finish.
Very good. Now moving to the next type of reaction, that is your basically addition of ammonia. Addition of ammonia and its derivative. So it's very simple. I'm going to write a point about this. Nucleophiles such as ammonia and its derivatives H2NZ add to carbonyl group of aldehydes and ketones. So it's very easy to understand. You know the formula of ammonia is basically your NH3. So if you are going to replace this one of the H with any Z, Z is basically your either it will be alkyl, aryl, hydroxide, NH2, C6H5, NH, NHCONH, NHCO, NH2, etc. If this this one of the H is or this hydrogens will be replaced by these groups, that is called ammonia derivatives. So how the reaction is taking place, it's very easy to understand. If you are going to react this either ammonia or ammonia derivatives, let's say H2NZ. So it's very easy to understand. This will be, there will be formation of negative and positive as well in the same way, and there will be OH and then NHZ. How it forms, it's very easy to understand. As you can see, hydrogen is lowest electronegative, so one of the hydrogen will go to oxygen because oxygen is negative and hydrogen will be positive. So OH and this whole NHZ will be negative. So I'm gonna write, I will explain it again, so please do write it up to this. And after this, C double bond Z, sorry, NZ, and this will be formed. I'll explain the reaction first, right?
Yes, sir. Finish.
Very good. So I'm going to explain this reaction. Have you understood or should I explain it? Same process is following. Nafisa, as you can see, C double bond O, and then can I write this H and then uh, NHZ? Can I write this? Yes or no? Nafisa.
Yes, sir.
So this will have negative charge, this will have positive charge. You know that this will have negative and this will have positive. So it will go with this. So it is forming single bond
Sir,
now.
NH2Z, right?
Yeah, it was NH2Z. So can I write this is Z? So can I write, if you are going to write this, it will be hydrogen, hydrogen, and then Z. So
Yeah,
according to
yes.
requirement, can I write this NHZ or NZH
Yeah,
like this?
yes, sir.
So this H plus will go to this, and you can see this carbon will have positive charge, and you are watching or seeing the negative charge here. So it will attack directly on carbon, and it will form NHZ, right?
Yes, sir.
Now you can see I'm gonna write this and Z NZH. Can I write this? And then remove,
Yes, yes.
this H2O. Remove this H2O. So if you are going to remove this H2O, this will be like this. So in order to satisfy itself, it is making double bond. Okay.
Yes, sir.
How's your nomenclature going?
Um, I've been studying for other subjects.
What you just said, you haven't studied.
No, I've been studying for other subjects because I have exams right now. So yeah.
Okay.
Sir, can you scroll up?
Yes, why not? Let me know when you're done with this.
Yes, sir, finish.
Okay, so let's go for the next. Uh, these are all interrelated with the previous chapter, chemical properties, this reduction. So we will not take that much time in this reduction. So as you can see that for reduction, you have first part is a reduction to alcohols, reduction to alcohols. So if you are going to use a primary aldehyde and using a reducing agent like sodium boron hydride NaBH4, it will be converted into what? Alcohol. Primary alcohol. This aldehyde will be converted into primary alcohol. Primary alcohol. And if you are going to use, see how the reaction took place, you know that RC double bond OH that we have already studied it, and alcohol, phenols, and ethers. One of the bond will be broken, hydrogen will be added here, and hydrogen will be added here. Now you can see RCH was already there, and after reaction, this hydrogen comes, so RCH2, and then it becomes OH. Is that clear?
Yes, sir.
In the same way, if you are going to use a uh, this NaBH for reducing agent, this ketone will be converted into secondary alcohol. Secondary alcohol. And same reaction is the reaction process is same. As you can see, one of the bond will be broken, H and H. RCH, R dash, and OH will be formed. Okay.
Yes, sir.
Please do write it. Let me know.
Yes, sir, finish.
Very good. So this was the first, second chemical reaction of aldehyde and ketones. Now the third is basically your this is not the basically third part. It is the second part of the second, that is a reduction to hydrocarbons directly to alkane. Basically, reduction to hydrocarbons in which we got two important name reaction, and there is, as you can see, if you have the first is basically Wolff-Kishner reaction, Wolff-Kishner reduction. or Clemenson reduction and Wolff-Kishner reduction. So I'm going to write the carbonyl compound. Write with me. The carbonyl group of aldehydes and ketones are reduced to CH2 group on treatment with zinc amalgam and concentrated hydrochloric acid. It's very easy to understand. See, I'm going to write the reaction. As you can see, if you are going to use this, if you have an aldehyde or ketone and you are going to use zinc amalgam, that is ZnHg. That is ZnHg in the presence of HCl. What will happen? It's very easy. One of the bond will be broken. Hydrogen will be added to here and here. Another bond will also be broken. Hydrogen will be added here and here. And you will get a hydrocarbon. And this reaction is known as Clemenson reduction. Clemenson reduction. Is that clear?
Yes, sir.
Please do write it and then let me know.
Yes, sir. Finish.
Now there is another type of name reaction, that is Wolff-Kishner reduction. And I'm going to write a point about this. This aldehyde and ketones are reduced to hydrocarbons on treatment with hydrazine followed by heating with sodium or potassium hydroxide in high boiling point solvent. In high boiling solvent such as ethylene glycol, and this is basically known as Wolff-Kishner reduction. Wolff-Kishner reduction. The name reaction is Wolff-Kishner reduction. I'll give example of this as well. So please do write it.
Yes, sir. Finished.
Very good. So I'm gonna show you the reaction. I will explain the reaction as well. It's very easy. You can see this is your C double bond O, and then if you are going to react this with NH2 that is hydrazine, there will be elimination of water, that is H2O, and it will give you C double bond N, and then NNH2. I will explain this reaction. And after this, you are going to react this with boiling solvents such as KH or potassium hydroxide, and this is your ethylene glycol is your solvent, ethylene glycol, and you are going to heat it. Then you will get CH2 and NO2 and 2 will be evolved. I'm going to explain the reaction. See here. C double bond O. This is like this, and I'm going to write this NH2. As can I write this H2N and NH2? Can I write this? Yes or no?
Yes, sir.
So in the first step, you are going to remove water minus H2. That means basically what you need to do, just remove this and add this double bond carbon to nitrogen. So it will form like this. Yes or no? And
Yes,
after
sir.
adding this KOH and ethylene glycol solvent, one bond will be hydrogen, hydrogen. Another bond will be hydrogen, hydrogen. So it will form basically CH2. And this is your Wolff-Kissler reduction. Please do write it.
Yes, sir. Finished.
Very good. So, okay. Now see, I'm gonna give you, what about your nomenclature? Did you practice anything?
Not yet.
You need to write the name of all the compound and send it to me with the question. Okay.
Okay, sir.
Wait a minute, please. CH3, CH, then CH3, then CH2, CH2, CHO. This is C2H5. Okay, can you look at this? Nafisa,
Yes, sir. I was taking a paper.
okay, okay. This is your C2H5, okay? Wait, let me.
Okay.
So you are going to solve it and send it to the WhatsApp, okay?
Yes, sir. Okay.
After solving it, you may leave the meeting.
Sir, number 4, what is that P?
Yes, please forward it to that number, WhatsApp number.
Sir, number 4, P. The P.
P is for para.
Okay.